Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using the PowerBasic Windows compiler. Today we will begin our project to look at the use of text prediction software. Today we are starting a new project. I've wanted for some time to do a project on artificial intelligence and machine learning. And today we're going to dip our toe in the waters of machine learning with predictive text. Most people will have used smartphones to send text messages. And one of the features of sending text messages is predictive text, where the application will predict the next word you could use in your text message. So in this project, we're going to look at what's needed to create a predictive text system. We're going to be using the PowerBasic Windows compiler to do this. As you will see on screen, we have a fairly simple application. This application has a toolbar which has two buttons, one to add text data and one to save text data. We have two boxes on the screen, one a simple text box to allow the user to type text in, and on the right we have a list box into which are going to appear the words that the system predicts the user may use. So as this is a machine learning system, where's our data going to come from? For the great many videos I've posted on YouTube, the majority of them have subtitles. And it is some of these subtitle files we're going to use to drive our system, to provide it with sufficient data in order to work out prediction of text. If we have a look at one of these subtitle files, we will see it comes in a series of phrases. These have time slots to indicate where in the video this particular piece of text is spoken. So in order to use this data, I wrote a small program to strip this data out to leave us just with the text. If we run this application, it will create a number of text data files. If we open these up, we will see this has the raw text. This is stored in one long line of text, and this is the data we're going to use to drive our system. For example, if we take these three words here, in this series, we will store these patterns of three words inside an array, and we will count how many times this particular pattern appears, so that when a user types in this, we have a probability of knowing what's the next most logical word the user is going to use. And with all machine learning systems, we have to feed it a great deal of data. To start this off, I have created 10 of these text files. The files are individually not very large, but they do contain enough information to start us off. So let's have a look at the code. As you will see from the beginning of the code, we have a couple of include files here. We have a PB toolbar library, which we're using to create our toolbar at the top of the screen, and we have the file handling routines library, which we've used in many previous videos, which contain functions to allow us to read and write from text files. So in order to perform this text prediction, we're going to store the data in two arrays. One string array to hold the information of words, and one numeric array to hold the count of the patterns. This way we can work out how many times a particular three-word pattern appears in our data. So there are our two arrays, word data and word count. And we're going to start these arrays off with 10,000 elements. This is enough to start off, and we may want to increase this. So I've set another constant called array block to be the number of elements to expand the arrays by when the need arises. Therefore, the application will extend these arrays as required. And we've created three string constants: word data, word count, and word data CSV. The word data text file is a dump of the data held within the word data array. The word count text file is a dump of the data held in the numeric word count array. The idea behind this is once we have trained the system, we'll want to save the information, so that the next time the application is run, it can load up this preloaded data. And the final file I'm outputting is the CSV file. This is a combination of the word data and the word count arrays. This will allow us to look at the data to see how it's progressing. So within our PB main application, we're going to dimension these two arrays, initially set to the star size, which is 10,000 elements. In order to provide the data in the 10 text files to the application, we're going to put some code behind the Add Text Data button on the toolbar. So let's go to the event handler, the callback function of the dialog. In the command section here, we're going to put a piece of code to pick up when the user has clicked on the Add button. This uses the standard check to see if the user has clicked the button. And we're going to use the display open file command to allow the user to select one or more files from the disk. We're setting the flags to insist that the file must exist that the user is selecting, and we're going to allow multi-selects to allow the user to select more than one file at a time, as we have 10 files we want to feed into the system. The display open file command takes a number of parameters. For example, the handle of the payment dialog, the title you wish to show, the path to where the files exist, and the pattern that you're looking for. In this case, we're looking for anything with text data and followed by an underline, and are all text files. And we're returning that to a variable called strFile. And we're counting the number of files the user has selected, as since we've set the flag for multi-select, the user can select more than one file. And we'll need to process this data, so we're going to create a new function called processFiles. And to that function, we'll pass a number of parameters. The path containing the files, the handle of the payment dialog, the status bar, as we can give feedback to the user, and the file count, the number of files that the user has selected. The way the display open file command works, if the user selects a single file, then the strFile variable will contain both the path and the name of the file. If the user selects more than one file, then the strFile string will contain a series of values, delimited by a null value, a CHR$0, and we'll cover that within the processFile command. So let's go and create this new function. So here is the skeleton of our new function taking its 4 parameters. And in order to handle multiple files, we're setting up a number of local variables. One called file to hold the individual name of the file, and a file handle, and a folder. Since the value in the file count could be 1 or greater than 1, we need to test to see if this is a single file we're getting in, or is it going to be multiple files. If it's a single file, then we can populate the file variable by using the parse command, and using CHR$ as our delimiter. Then we're going to call a new function, processFile. The processFile function is dedicated to processing a single file. And if it's going to be multiple files the user has selected, we need to do this slightly differently. We will pick up the folder as the first element of the files string. Then we can use a simple for next loop to iterate through that string to pull out the information. We can set the text to be the loading file message to say which file we're loading, and we can then work out the file name, again using the parse command. And for each of these files, we'll call processFile. This way, the same function, processFile, can be used regardless of whether it's one file or multiple files the user has selected. And after we've completed this processing, we will update the dialog on the status bar to say that the file or files have now completed loading by using a straightforward control set text command. So now that we've completed this particular function, let's go back to the callback function, as there are a number of variables at the beginning of the function we'll need to declare. So we have file, which is the selected input file, flags to be the file selection flags to allow the user to select more than one file at a time, and an error variable which will contain any data we need to pass back to the user to say what the problem is when something has failed, and file count, which is a count of the number of files the user has selected. So our next task is to process the individual file. So let's go and create that function. So here is the skeleton of our new function, taking in its three parameters: the file, the handle of the payment dialog, and our status. So we're creating a number of local variables. As we're going to be handling 3 words at a time, we have strings set up for the word, the second word, and the third word. So first, we will display a message on the dialog in the status bar to say that we are now loading a file. And we will dip in to use one of the functions in our file handling library, called binary file as string. This will load the entire file into a data variable. This will allow us to manipulate it in memory. And as all the words within this file are going to be delimited by a space character, we can then work out how many elements we've got, how many words exist in that string. We can do this using the parse count command and a single space delimiter. So now that we know how many words exist in the file, we can step through them using a standard for next loop. And the first line within this for next loop is to pick up the word we're dealing with, again using the parse command. In order to test out this function, we're going to need some small amount of data. I don't want to give it a full-size file, as it'll be easier to debug it if we have a smaller file. So this is the small file I'm looking at using. It has effectively only 3 sentences. One saying welcome, and one saying in this series of short videos, which is repeated. This will give us an easy way of actually picking the information up. For the structure that we have, if we have a sentence which has only one word within it, we're going to ignore this, as it ends in a period. Therefore, there is no text actually following it within the sentence. So we can do that in code quite easily. So we're testing the rightmost character of the word. If it is either a period or a comma, we're ignoring this word completely. And in our case else, we will handle everything else. So next, we need to get the next 2 words, the second word and the third word. Again, using the parse command, this time looking for the current word number plus 1. And again, if the rightmost character of the second word is the last in the sentence, there will be no third word following it, so we can ignore this one as well. As you can guess from the code we've seen so far, we're not going to do text prediction after each character is pressed on the keyboard, but we're going to use word prediction when the user finishes typing a word and presses the spacebar. That will be the trigger to look for the next possible word. And next we're picking up the third word, again using the parse command. For the third word, we are using the trim command. This allows us to trim things off the end and beginning of the text, and we're trimming either period or commas off the beginning or the end of the third word. As we're going to store these 3 words in a phrase format inside our array, we don't want any periods or commas cluttering it up. Next, we'll have to double check to make sure we do actually have a second and a third word. And we can do that quite easily by testing them individually. If they are not an empty line string, then we do have 3 words in a phrase. And we'll need to add these to our array. So we're going to create a new function called addToData, passing it 3 parameters, which are the 3 words. So now we can go ahead to create this new function to add to our data. So here is the skeleton of our new function passing in the 3 words. So our first task is to form these up into a phrase, delimited by a single space character. So we have the first, second, and third words in a new variable called phrase. Next, we'll need to handle any double quotes within the string. This is to make it easier when we're actually printing information out to our CSV file. So I'm going to use a couple of replace commands to replace double quotes and also carriage return line feeds. So we'll substitute a single quote for any double quotes that exist and an empty line string for any time a carriage return line feed appears in the text. Next, we need to scan our word data array for this phrase of 3 words. We can do that quite easily by using the inbuilt array scan command. This is a very powerful command. You can use it to scan through an array and collate it on uppercase. This means it doesn't matter whether it's uppercase or lowercase, and we're looking specifically for the phrase variable. It will return a value in the I variable. This is a long number. If the number is 0, then it's not in the array. If it is greater than 0, then the entry already exists in the array, with the I variable pointing to the element of the array. So if it is already in the array, all we need do is to increment the value in the word count array. This adds 1 to the value. So if the value is 1, it will now become 2. If it is not in the array, we'll need to add it into the array to slot it in. So we will create a new function called addToDataSlot, which will take our phrase and add it to the end of the array. So here is our new function, taking its single parameter, which is the 3-word phrase. We should at this point not actually have a phrase which is an empty len string, but this is a catch-all just in case. So we have 2 local variables, one for the index variable and one for the maximum number entries in the array. So first of all, we will populate this max variable to get the upper bounding of the word data array. This will allow us to use a for next loop to step through each element of the word data array looking for a blank entry. If we find an empty slot, then we can go ahead and add the phrase. So we add the phrase to that element of the word data array, and we set the count in the word count array to the value 1. At that point, we can exit the function immediately coming out of the for next loop, as we have found the slot into which we want to put our new phrase. As we're going to be feeding a fair amount of data into these arrays, we will come to the point where there is not enough room left in the array for any more data. So if we search through all of the data within the word data array and find there are no empty slots left, then we need to expand the array. So we can use the redim command with the preserve option. This allows you to increase the size of the array by a certain amount. And the constant we're using, array block, has a value of 1000. If you're going to be extending an array, it's good practice to extend it by a fair margin each time you need to do it, as it does take PowerBasic time to perform this extension. Therefore, if you're going to extend it by a fair margin each time necessary. This way it minimizes processing. So we're adding 1000 elements on to the end of the array. And now we can slot in the new value. As the max variable has the maximum number in the existing array before we redimensioned it, we can just increment that number and slot our value in. So there we are, adding on the phrase to the next available slot and setting the word count to the value of 1. So what we've achieved so far is we've allowed the system to pick up a file or files that the user has selected, process them into the array, and store the information. So let's try running the application and make sure it works. So now that we've completed the addToData function, let's try running the application now to ensure that there are no errors so far. So our application runs. If we click on the Add Text Data button, we should get the dialog to select our data. If we go into the data folder, and we will pick our very small file first of all, and hit the open button. And it's telling us the file has loaded. If we try it for multiple files, all the files are now loaded. However, we can't actually at the moment see the data. So let's put some functionality under the Save Text Data button so we can actually see the values we've stored in our arrays. So back to the code and into the event handler of our dialog. So we're now back inside our event handler, our callback function, and we've created a new event to handle the clicking of the Save button. And when this button is actually clicked, we will call a new function called SaveArrays, passing it an str error variable. This will contain any error that occurs during the save, and if that function does return false, we will display this text to the user, telling them what went wrong with saving the arrays. Otherwise, we will display the words "files saved" to the status bar, So let's now create the save arrays function. So this function is fairly straightforward. We will pick up the file name to save as being the current executable path plus the name of the data folder. And we're adding on to that the constant for the word data array. And we're going to be using the array dump function which exists in our file handling library. This takes a string array and dumps it out to the file. If that returns true, then the file has been successfully saved. And then we can define the name for the word count array. And we're going to use another function within our file handling library that will dump out our long array as a one-dimensional file, passing it the file name and path, the name of the array we wish to dump, and an error variable should any error occur. And if that returns false, then we report what the error is. If it returns true, then the file has been successfully saved. Next, we want to create a CSV file. This is a file purely for our human purposes of seeing what's in the database. This combines both the word data and the word count information. And we're going to create a new function to perform that called dump CSV file. And here is the final function within our application for today's video. Dump CSV file. Built within a try-catch loop, this attempts to save out our information to our CSV file, giving it two columns, one for the three-word phrase and one for the count, the number of times that particular phrase appears in our database. As we may well have many blank entries within this database, anytime we reach a blank entry, we just skip over it. And then we print out to the file our word data and our word count information. So if we try running the application now, we'll first of all add text data from the small file. If we open that, the file is now loaded and we can click on Save Text Data. So we've now saved a file back to our data folder. So if we have a look in our data folder, we can see we have a word count. If we open that up, we'll see we have a whole series of numbers. And if we look at the word data text file, we have 4 sets of 3 words. And if we look at the CSV file, we can see this quite easily has a count of 2 for each of these 3 sets of words. So our count appears to be working correctly. As you will see from the phrase column, we have stripped out any commas or periods. So if we run this for all of our data, and in this case we'll pick the 10 bulk files and click on Open. We're now loading those files, and in a few seconds it will have completed the loading and tell us that the files have loaded. There we are, the files are now loaded, so we will save the text data. The files are now saved, so we should now be able to go into our data folder and have a look. So if we look at the CSV file first of all, we'll see we have 10,000 records in this particular series. And as you will see, there are a number of large counts. For example, anytime the 3 words end of the appears, it appears 20 times. So we now have some data which we can use to work out probabilities of text prediction. If we open this CSV file in a spreadsheet, we can quite easily see where our prediction is going to work. We have 3 highlighted lines of text here, starting with beginning of. Looking at the count of each of these phrases, the most likely third word is the word the. It appears 10 times in our data, closely followed by the word hour, which appears 7 times, and the word a, which appears only once. So although we have only fed 10 sets of data into this machine learning system, we could feed many more. The more data the system accumulates, the more likely it is to have a better prediction as to the word that's next going to appear. So in summary, in this first video on text prediction, we have created a system to accumulate data. This uses the approach of taking 3 words as a phrase and counting the number of iterations that the system finds in the data. This gives us 2 arrays, one containing the 3-word phrase and one containing the number of iterations of that phrase. This data is going to be used in subsequent videos. However, that's it for today. Thank you for watching.